Okay, so now we're on to 6.2, and we have linear equations in one variable and proportions. So let's look at the idea of this section. We're talking about solving equations with fractions, solving proportions, problem solving with proportions, and identifying equations that don't have a solution or might have more than one or many solutions. So first of all, when I talk about a linear equation, that means it has an equal sign in the problem. Okay? And when I say solve it, I want to know what number you can put in for the variable, the x, and it makes it true. What number works for x? So when we're solving, we're getting a number out. When we have expressions that don't have an equal sign, we're simplifying, but we don't necessarily solve. We don't get like a solution um, to the problem like we will on these. Okay, so um, we're talking about equivalent equations here. So basically, this is the same as this. So when I say x equals -3, basically that's what solves this also. -3 times 4 is -12, plus 12 is 0. 0 equals 0. So these are equivalent equations. They're the same thing because the value that you put in for the x is the same. So for this one to be true, that x has to be -3, or x is -3. So when we're solving equations, we're just finding the value that works for that problem. Okay, addition property. If you see something like, well, okay, so you can add the same thing to both sides or subtract the same thing to both sides because adding a negative is the same idea. You could also multiply something to both sides of your equation. So up here, it's like I moved things around, but they were the same. So I could do that. That's legal. I could multiply by something. I could, as long as I do it to both sides, I could add something, but it has to be on both sides. Okay, so solving a lot of these, we're going to, I did create some steps here. You can pause and read through those um, and make sure you understand them. But the big idea is I want to get x equals a number so that I know which number x equals. And in particular, think of it as 1x. I want to know what 1x equals. So this first problem here, I want to find this number, what number I put right here, where I add 6 to it and I get a -10. So what number can I add 6 to and get -10? So the idea of opposite operations comes in. It's kind of undoing things. So I see a +6, so I'm going to -6, and I'm going to do that from both sides of the equation because that's a legal move as long as I do it to both sides. This one will go to 0, so you will have 1x or x left equals -10 minus 6 more is -16. You add them together because they're both negative and keep that sign. Okay, so think back our check. Does this work? If I have -16 plus 6, does that equal -10? Yeah, this is -10, which equals -10. So yes, right? The check worked. So it's kind of cool because when you have the equal sign, you can always put your answer back in and make sure it really worked. And you can use a calculator for that part if it's a real long problem. Problem 2. Well, right now I'm not adding or subtracting a number. What we're doing, I think every time I go to make a video for your class, I'm yawning, drinking coffee. I promise I'm not always tired. Okay, so problem 2, it is -3 times x, right? This is like times right here. So -3 times x. So what number can you times -3 by to get +24? Maybe you already know it. You just said the answer. Great. If you don't know it, you can do the opposite operation, which is to divide. So if I see times, I can divide to find that answer. On this side, it becomes 1x, which we want. We don't have to write the 1, but we can, equals 24 divided by -3 is -8. right? -8. Okay, so on that thing, like, think about it though. If I go back in and I think -3 times -8 for our check does get me positive 24. So -3 times -8 equals 24. Yes, it does, right? Yes, so the check worked. Okay, so if we see times, we divide. If we see add, we subtract. If we see subtract, we add. So we're always doing that opposite to kind of move those numbers away from the letter so I can solve that equation. So problem 3 is division. What number divided by -4 is going to equal -2? Okay, so when I see division, what's the opposite operation of division? It's going to be times. So on this one, I'm going to times both sides by -4. I kind of had to write it on that left side for that one just because that's where I have room. Think of it as over 1 if you want to with the fractions. So you should be able to see that these would cancel and you still only have 1x left over. And then on the other side, a negative times a negative is a positive, so I get +8. And let's check that. Is 8 divided by -4, does that equal -2? That's our original. And yes, yes, it does. It ends up being -2 equals -2, which is true. I mean, you could write that if you wanted, but yeah, it worked. Okay, last one, number 4. This one comes up a lot. You could think of that as like a -1 times x, or I mean, somehow you have to think of that as I need to divide by a -1. So I'm going to divide both sides by -1 so that that is a positive x equals -6. Because negative x equals 6, we don't, that's not a solution. That's not 1x. You're saying a negative x. I'm saying the opposite sign of what the answer is. So if you can't stop with negative x, you have to divide by negative, and that just switches your sides. Whew, now you're going to have the yawns. I'm so sorry. I'm trying to not yawn. Maybe it's entertaining for you that your teacher yawns every time she tries to make a video. Okay, two-step equations. So we're starting to add more steps. So the 4 steps we just did are like the main 4 ideas for the class. I mean, for solving, not for the class, but for solving equations for this topic. Now let's mix it up. When I'm looking at this one and I'm solving for x, still want to see what number goes right where my red dot is. So 4 times what plus 5 will give me 29. I want to start with the number by itself and opposite operation. So basically, I'm going to move that 5 away and do the opposite. So that cancels. So now I have 4x equals 29 minus 5 will give you positive 24. And from here, then we see division. So I always want to add or subtract the numbers away first. Now I'm going to see, I see time, excuse me. So I want to do division. I'm kind of mixing that, my thought process there. So x equals 6. Now go back to the original for your check. Is 4 times 6 plus 5, 29? Sure, that's 24 plus 5. And that is 29. So yay. Our check worked, right? Okay, this next one, number 2 on this section, our x value is over here this time. So I still add or subtract the number over. Now think about it. This minus goes with this 2. So this is a positive 7. So to move it, I need to minus 7 to both sides. So that goes to 0. Negative 10 minus 7 more is negative 17 equals negative 2x. Then for this one, I'm going to divide by the negative 2. So the x is on the other side. I still want it to be 1x. So if I divide by negative 2, that will become a 1 there. And divide by negative 2. This becomes a 1. Now look at 17 halves. 17 is not divisible by 2, but you formed a fraction, and that fraction is the answer. Can you reduce that fraction? Yeah, a little. A negative over a negative is a positive, but 17's prime. So, I mean, really all we can do is write it as this equals x. Some of you might have thought of the mixed fraction. So like 17, 2 goes into 17 8 times and 1/2. Okay, that also could be the solution, either one. So for this one, if I wanted to check the answer, this is one where I'd probably get out my calculator and I'd say, okay, for that right side, 7 minus 2 times, and in your calculator, you could go 17 divided by 2, okay? And that will give us the negative 10. So I'll show you that over a little bit right there. That's how I can just type it in just like that, and it'll give you the answer. So you can use division as a fraction. There's also fraction keys on a lot of calculators where you can actually type it in as a fraction, but the division key works. Okay, so I double checked on the calculator and it worked. So we're starting to add more and more steps. So as we look at, I just called it more steps, multi-step, right? So we might have to distribute like we do on this first one. Yeah, or go across an equal sign like we will on the second one, but we're just going to simplify this left side. Okay, so ignore this and just simplify this before you start going across. Okay, so I'm going to say, all right, 6, this 3 times 2x is 6x. 3 times 1 is a minus 3. Still have my plus 7 equals negative 2. Now I want to combine the 7 and the negative 3 because they're just numbers. So now I have 6x plus 4 equals negative 2. And now this looks like the problems we just did. So we know we want to move the 4 first. So we're going to minus 4 from both sides. And we'll have 6x equals negative 2 minus 4 is negative 6. Okay, now divide by 6 on both sides, and x will equal 1x, right? 1 equals negative 1. All right, so the check again, put it in your calculator just like you see it. C3 parenthesis 2 times negative 1 minus 1 into my parenthesis plus 7. What does that equal? It equals negative 2. Okay, it equals negative 2, which is good. All right, so we know our check worked. Okay, so for problem 2 on this section, you have a term with an x on both sides. So what you could do is you could still do the opposite operation across the equal sign, kind of like, all right, I see a 4x, I'm going to minus the 4x over. So I'm going to think of it like this. I am going to minus the 6x over to the other side. And I have to combine it where the x is because we already went over this. You can only add together like terms. So I'm going to move the x's together. That makes 0 of them over here. 4 minus 6 is negative 2x. Still have my minus 7 equals my positive 7. Now I moved it to the left. You could have gone to the right and you still could end up with the same answer. I move it to the left because it'll help with the next section. And I always try to do things in the same method as best I can to help with clarification for people who really struggle with this kind of stuff. Okay, so I'm here. So now I have negative 2x minus 7 equals 7. And I have to add the 7 over to the other side to get rid of it from here. So now I feel like I need a line right here. So now I have negative 2x equals 7 plus 7 is 14. Okay, I see times, so I'm going to divide to get the 1x. And I get 1x equals negative 7. Okay, to check this one, you have to calculate both sides. So you'd have to think 4 times negative 7, which is negative 28, minus 7 more is, I don't know, what's 28 plus? I can't figure that off the top of my head for some reason. 28 and 35. So I got negative 35 on the left. Now on the right side, 6 times negative 7 is negative 42 plus 7. So negative 42 plus 7 is 35 as well. And both sides are negative 35. Okay, didn't write negative on there, so then I threw myself off, but they both were, I was like, it's not the same. It's one's positive, one's negative. They are the same. I just didn't write the negative on my thing. Okay, so this is our answer here. All right, so let's go into a ratio. What is a ratio? Well, we've seen it before when we did um, sequences. It was called a ratio between two numbers. And that's all it is it's like a division, a fraction. You're comparing two values. So a ratio can be written as like 30 to 40, 30 to 40 like this, or as a fraction. And it's just comparing two things. Like even if I said I have a ratio of 1/2, I have 1 to 2. Like that's the comparison between the two things. Okay, so we have a ratio, and when we go to do a proportion, we have two ratios equal to each other. And to solve these, we do something called cross multiplication. So we go B times C is equal to A times D. And that's what this is showing you. So if we have a fraction equals a fraction, we can cross times them and no longer have a fraction. Yay! Okay, let's look at a problem. Oh, of course, I didn't do an easy one. Let's do problem 2 first. So we have a fraction equal to a fraction on problem 2. So 7 times x this way, right? We like to write that as 7x. We don't really like x7. It's just weird looking. Equals, what is 63 times 5? I don't know. What is 63 times 5? 315. I said 15, but I wrote 17. So there we go. Okay, all I did is cross multiply. Now to solve this, I know I need to divide by 7. I don't know if that does it. It does. So x is 45. So the original ratio of 63 over 45 is the same as 7/5. So you could divide both fractions and you better get the same answer. Or 63 over 45 should reduce to 7/5. And it does. 3. Yeah, because it's 9. 9 goes into 63 and 45. So, okay. Now let's look at this top one that I kind of skipped. So we're going to cross multiply, but be careful. Think of it as 30 times x minus 10 equals 20 times x. So just keep it in a parenthesis because the 30 has to be times by the x and the 10. So if it has more than one term, whatever will help you remember, put a parenthesis around the more than one term. Okay, then I multiply that through. 30 times x is 30x. 30 times 10, excuse me, and it has a minus in between, so you can think of it as a negative 30 or 300, excuse me, or you can do plus a negative, however you want to think of that, equals 20x. Okay, now I have two x's, so I need to add or subtract them to the other side. So if I go this way, like I like, then you're going to have a 0, which is a little weird, but I'm still going to show it. So basically, I need a negative 20x over here to the x term. Don't try to combine that with your 300. That's not going to work. Okay, and then I'm going to finish it up here. So 30 minus 20 is going to give me 10x. I still have minus 300, and now it equals 0. Just don't drop off the equal 0 if everything moves to one side. All right, and then I'm going to add the 300 to both sides. And I'll have 10x equals 300. Okay, now divide by 10, and x is 30. Whoosh. We go over here. 30 minus 10 is 20. 20 over 20 is 1. 30 over 30 is 1. Cool. This one is the same problem. I don't know. I was trying to think if I meant for it to be something different. Just the accidental typo. Okay, so problem 4, we have fractions in our problem. So using the idea of multiplying by something, I can actually get rid of my fractions. So it isn't a fraction equal to a fraction, so I can't cross multiply. I want a different method. So what I'm going to do is I'm going to multiply by a common denominator. I love this method. So look at 4. What are the two denominators you have? You have 2 and 7. So we can just times them together. I'm going to multiply everything by 14. Okay, I'm going to do it as a big parenthesis and multiply everything by 14. All right, now watch me write this out. So I'm going to have 1/2 x, right, times by 14 over 1 minus 14 over 1 times the 3 sevens equals 14 times -3. I wrote it in front because I went to write it behind and it looked weird with the x, so we'll just write it in front. So did I times 14 by every single term? Yeah. So it's here, right? This term has a 14, this term has a 14, and this term has the 14. Then I simplify it, and it looks harder than it is. 2 divides into 14, leaving 7. 7 times x is 7x. Okay, 7 divides into 14, leaving a 2. 2 times 3, right? 2 times 3 is 6, and it's a minus sign right here. So we're going to have -6 equals, what is 14 times 3? Oops, 14 times 3, 42. And it's a -42 because it's a -3 times a +14. All right, keep going. Now look, wait, pause. No more fractions, just admire. Which one do you want to solve? This one or this one? I like this one way better. So you can multiply by a 14, and get rid of all denominators. It's amazing. Or you could add, subtract with fractions, get your common denominators. Don't forget your rules for multiplication. A lot more room for error, in my opinion, but you can do it that way. So now I only have a couple more steps and I'll have my solution. Add my 6 over and I have 7x equals 42 minus 6. I don't know why I thought I needed a calculator for 36, but I did. And it's a negative. See, got that in there. And then divide by 7, and you go to x equals 36 sevens, which I think is, you'll have to leave it at that because it doesn't reduce. So your answer is probably, I'll just clean it up a little, just the -36 sevens. 7 goes into 36, 5 and 1/7 time, but I don't think it matters if you do that part or not. Okay. I think you can leave it improper. I think it prefers improper, as a matter of fact. Okay, and if you miss a problem on a quiz or in a homework because you had the wrong format, just send it to me. I'll give you partial credit. I'm not gonna give you full credit because they usually tell you what form to put them in, but I'll give you partial. Okay, couple more problems here. Problem 5. The property tax on a house with an assessed value of 48. I just said that weird, but that's all right. 480,000 is 5,760. Determine the property tax on a house that's assessed at this value at the same rate. So watch what I can do for proportions. I love using these in real life. So I know right now I have a tax of 5,760 for a house that's at 4,800 for value. And I know that I want the other one to equal 600,000 for the value, and 1, 2, 3, 1, 2, 3. Okay, commas in here and we don't know this tax value here. So we can set up a proportion where the tax value, you could have had these switched the other way. So it could have been 480,000 over 5,760, and then the other one 600,000 over t. Like, you're gonna get the same answer. So there's a couple ways we can set this up. There's actually more than I just said even. So I just think of, well, we have the full example, so form a fraction. And then this better equal what this is talking about. This better be the same as what this one's talking about. Now I can cross multiply. So this one times this one is 480,000. T equals, I don't know, a huge number. So 600,000, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 times 5760. Oh my goodness. I knew it was going to be big. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. It's in the billions. That's how much money I have in my bank account. Just kidding. Now divide 480,000 into this big old number, and you'll have your solution. So I have that number still in my calculator. So I'm just going to hit divide and put in 480, 1, 2, 3, and I got $7,200. All right, so the numbers are a little ugly just because they're big, but we can totally use this idea of a proportion. Let's look at another one, but a little different situation. A wildlife biologist catch and they tag and they release deer back into the wild. So they did 135 deer back into the wild. 2 weeks later, they only observe a sample of 140 deer and 30 are tagged. Assuming the ratio of tagged deer is a sample that holds true for an entire population, how many are there in the refuge? So they use this method all the time. So it's like, okay, I'm going to catch some, I'm going to tag them, I'm going to release them, then I'm going to get a sample and see how many are tagged. Okay, so let's form our proportions out of this. Okay, so form your proportions. The ones I know for sure are 30 tagged deer out of 140. I know that for sure equals, I don't know how many. Oh, wait, no, I have 135 tagged. Excuse me. So tagged is 30, tagged was 135. And then I don't know how many total in that population. So the top numbers are tagged. Okay, they're the tagged ones. The bottom numbers are the total population. And then solve it, cross multiply. So 140 times 135 is 18,900 equals 30 times X. So then we divide by the 30 and I get 630. So we are going to estimate that there are 630 deer according to this tag method out in the wild. So I did it with taxes. I did it with, and I do this all the time, like in my brain. I'm sure you do too. Like even things like 2 large pizzas feeds my family of 5. So if I'm having 25 people over, how many pizzas do I need? That is a ratio and a proportion. I don't always have to set it up and solve it, but I do in my brain. Okay, last idea here is, did you know when you sometimes go to solve things, they don't have a solution? They're the harder ones because like, I want a number, I want an answer. And this happens a lot in real life, like it doesn't work out. And that means either it doesn't work in real life or you set it up wrong. I mean, either one. But we could have something that has no real solution. Okay, so it could have no solution. When we're solving, we're going to end with something weird like 0 equals 4. Well, 0 can't equal 4. Or even 4 equals 7 or 10 equals 12. Like none of that is true. So if you get a weird answer and all of your letters have disappeared, you probably have no solution or many. Now, many solutions means anything will work. Any number is possible. So then you get an answer like 7 equals 7. Again, you don't have X in there anymore. It used to be like X equals, but they both of these samples, they no longer have the variable. So let's look at a problem and we're going to solve exactly like we have been. So on this first problem, I'm going to leave 2x plus 6 over here, but this side I need to times it through. So 2x plus 8. I needed to distribute the 2, right? 2 times x, 2 times 4. Now I'm going to get my x's together. I can't simplify on the left or right anymore. So I'm going to move it over and it's positive. So I'm going to minus 2x and minus 2x. So on both sides, minus your 2x. What happens to all your letters? They went away. They're all 0. What do I have left? 6 equals 8. That's not true. So there's no solution. So that's what I mean by you get something weird like 6 equals 8. Notice that our variables disappeared. If you think back to what this is asking from here, it's a little easier. Is I times by 2, same number, and then add 6 and add 8. You can't ever get an answer that works. You can't, because 2 times the same number is going to be the same thing, and then I can't add 6 and add 8 and ever get there. So it just doesn't work. Okay, let's try this next one. So the left side, I can't simplify. So it's going to stay 4x plus 6 because I can't add a 6 to an x. Now distribute over here and I get 6x plus 6. Still have that minus 2x. Now on that right side, I can still combine the 6x and the 2x. 6 minus 2 is 4x. So now I have 4x plus 6. And I have 4x plus 6. So I simplified both sides. What do you notice before I move on about both sides? They're equal. They're the same thing. So no matter what number I put in, that's going to work because I'm timesing by 4 and adding 6. So if I put in a 1 on both sides, 1 times 4 plus 6 is 10. If I put in 1 or 2 on both sides, 2 times 4 is, I can't do that one as quick, 8. 8 plus 6 is 14. 8 plus 6 is 14, right? Okay, so let's look at what we do here. If we're just moving along, the process says, okay, minus 4x for both sides, and they disappear, and I have 6 equals 6, which is true. So then I have many solutions or infinitely many. There's a symbol for infinitely many solutions. It's probably A and B on your homework, and you pick B if it has infinitely many or A if it has no solutions. All right, that's all I got for you. That was a lot, but please reach out if you have any questions.